Now, scientists find a way to draw oxygen from salt water on Mars. The new electrolyzer system created by researchers at the Washington University in St. Louis can extract oxygen and hydrogen directly out of briny Martian water. One of the biggest challenges of sustaining future human settlements on Mars is to provide for enough resources for astronauts to thrive in the harsh Martian environment. Oxygen, it stands to reason, is perhaps the most important of them all. Hydrogen comes a close second. But converting the resources available on the planet to make them usable is no easy task. We now know that frozen water resides below the Martian surface. There's fresh evidence of salty, brine lakes under the planet's surface, but you can't drink salty water. Nor is breaking it down into oxygen and hydrogen using electrolysis, with the help of electricity, feasible. Pure water would be much easier to process, but there's none of that on the red planet. But now, researchers and engineers at the Washington University in St. Louis have created a novel system, a brine electrolyzer, that doesn't require pure water to extract these important elements. The research team, led by Vijay Ramani, the Roma B. and Raymond H. Witkoff Distinguished University Professor in the Department of Energy, Environmental and Chemical Engineering, didn't simply test this brine electrolysis system under usual terrestrial conditions on Earth. The team also examined it in a simulated Martian atmosphere at -33 degrees Fahrenheit, -36 degrees Celsius. The system can extract oxygen and hydrogen directly out of briny water, without the need for heating or purifying the water source. A Martian brine electrolyzer radically changes the logistical calculus of missions to Mars and beyond, Ramani said in an official release. This technology is equally useful on Earth, where it opens up the oceans as a viable oxygen and fuel source, he adds. The findings of the research were published on the 30th of November in the Proceedings of the National Academy of Sciences journal. It was in 2008 that NASA's Phoenix Mars lander sampled the planet's ice, soil and atmosphere. That mission was one of the biggest steps forward in our constant quest to search for water on Mars. The European Space Agency's Mars Express is another mission that continues to search for traces of water on the Martian subsurface. Water is not only a potential indicator of life, but pivotal for future space exploration and manned spaceflight. The Mars Oxygen In Situ Resource Utilization Experiment, simply known as MOXIE, is another scientific instrument that is working towards the bigger goal of producing oxygen from the Martian atmosphere for propellant and breathing. MOXIE is currently on board the Perseverance rover, which is aiming to land on the Jezero crater on Mars in February 2021. The current test model of this instrument is the size of a car battery, but according to NASA, future oxygen generators would have to be 100 times larger to support human life on the planet. Interestingly, the system developed in Ramani's lab can produce 25 times more oxygen than MOXIE using the same amount of power. It also produces hydrogen, which could be used to fuel return trips for astronauts. Typically, water electrolyzers use highly purified, deionized water, which adds to the cost of the system, the release explains. A system that can work with suboptimal or salty water, such as the technology demonstrated by Ramani's team, can significantly enhance the economic value proposition of water electrolyzers everywhere, even right here on planet Earth, the release adds. Having experimented this new system in simulated Martian conditions, the researchers now intend to deploy it in much milder conditions and generate hydrogen, oxygen through seawater electrolysis. Please save the trees and nature. Please subscribe to our channel. Thank you.